Hey there, guys. Today we're going to talk about the different types of angles that you get when a parallel line is cut by a transversal. Okay, so this is what we need to know right here is that we have parallel lines. So this is the symbol for parallel. It's two vertical lines closely together like the LL of parallel. And this is the symbol on your drawing. So here we have an arrow and here we have an arrow. In this case, triangles. So these lines are parallel, and then this is your transversal, the line that is crossing them. Okay, and as you see, there are 8 angles that are formed when we have parallel lines that are cut by a transversal. So let's talk about the different angle names. Okay, these are the types of angles that they are. So the first type of angle that we talk about are these corresponding angles. Okay, corresponding angles. Corresponding angles are in a corresponding position, okay, which is not a very good way to describe this. But if we look at it, here are some examples, like angle 8 and angle 6 are a pair of corresponding angles. So here's angle 8, uses the transversal and this line, okay, and then here's angle 6. Okay, so they're using the same transversal, and they're basically in the same position relative to the parallel line, right? They're both, I guess, on this side, maybe on the north side of the parallel line, and they're on the left side of this transversal. So they're in a corresponding position. Okay, so we're just going to call this the same position relative to the lines. Okay, the way it relates to the lines. So 8 and 6 are a set of corresponding angles. Okay, and there are lots of other ones. In fact, we can go with the one across from it. So angle 1 and angle 3 are also a set of corresponding angles. They have that same transversal. They're on that same positioning in respect to the parallel line and the transversal. So angles 1 and angle 3 are also some corresponding angles. Okay, and then we have their friends over here. So 2 and 4 are also in a corresponding position. So corresponding 2 and 4. Okay, and then the last set, as you might be able to guess, are 7 and 5. So 7 and 5 are also in a corresponding position. Okay, angle 7 and angle 5. Okay, now the relationship here is we're looking at their measures. Okay, their measures are in fact going to be equal. So the algebra that we're going to do is you're going to set the equations equal, right? So if we know angle 8 and angle 6, then you set their things equal. Okay, and that's the corresponding angle postulate that says corresponding angles are congruent, which means their measures are equal. Okay, so the next little set of lines we're going to talk about are alternate interior angles. Alternate interior angles. Okay, so alternate interior angles, the word interior, so they're going to be between your parallel lines. And alternate, they're on opposite sides of your transversal. Okay, geometers are not very creative in the way that they name things. So alternate means like opposite sides of the transversal, and interior is between your parallel lines. So these are alternate interior angles. So as an example, some alternate interior angles like angle 2, so we're between the parallel lines. Angle 2 would be the same as angle 6. So these are a set of alternate interior angles. Okay, they're on opposite sides of the transversal, and they're on this between your parallel lines. Okay, and then the other set, if you're looking, would be angle 7 and angle 3. So there's your parallel line. We come down your transversal, and then we go out the other parallel line. Angle 7 and angle 3 are alternate interior angles. Okay, and if we're looking at these ones, there's another postulate that says alternate interior angles, as theorem, that says they're equal. And there'll be a proof of that theorem a little bit later. But for right now, know that alternate interior angles have the same measure. So angle 2, measure of angle 2, is the same as the measure of angle 6. And the measure of angle 7 is equal to the measure of angle 3. Okay, lots of good things here. So the next one, we'll stay on the same one, are alternate. So alternates with exterior angles. Okay, alternate exterior angles, their position, just like before, are on the outside of your lines. Okay, alternate exterior. So exterior means outside. So outside of your parallel lines, and still on opposite sides of transversal. Okay, opposite side of the transversal, pardon me. Okay, so some examples here might be angle 8 and angle 4. Okay, so once again, here's your transversal, and there's that parallel line. So we can continue down your transversal, and here's the one on the opposite side and outside of your parallel line. So angle 8 and angle 4 are alternate exterior angles. Okay, similarly would be angle 1 on the outside of your parallel lines would match up with angle 5. So angle 1 and angle 5. Alternate exterior angles, opposite sides of your transversal and outside of your parallel lines. Okay, these ones are also going to be equal. Okay, and there's a theorem that says why they are that way too. So we have corresponding alternate interiors and alternate exteriors, all that are equal to each other. Okay, every single time we have one of these pairs, they happen to be equal. Okay, but now we have another set that are not equal. Okay, and they are a part of the consecutive angles. So consecutive interior and consecutive exterior. So consecutive means, right, the direct one following, right, consecutive numbers, 1, 2, 3, 4. So it comes from that idea that these angles are right next to each other. So consecutive interiors are between your parallel lines and on the same side of your transversal. Okay, so these are between the parallel lines, just like the interior angles before, but they're on the same side of your transversal. Okay, so if this is your parallel line set here, and this is your transversal, then these ones, angles 2 and angle 3, would be a set of consecutive interior angles. Okay, they're on the same side and they're between. So I'm guessing you can guess what I'm going to do next, and that's color these other ones. Angle 7 and angle 6 are your other pair of consecutive interior angles. Okay, now these ones add up to 180. So the vocabulary word that means adding up to 180 is supplementary. Okay, consecutive interior angles are supplementary. They add up to 180 degrees. Okay, and then the last set, your consecutive exterior angles, are outside of your parallel lines, and they are still on the same side of your transversal. Okay, outside of parallel lines, but on the same side of your transversal. Okay, so here's your parallel line, here's the other one, and here's your transversal. So angle 8 would go with angle 5. These would be consecutive exterior angles. Okay, They're outside of your parallel lines and they're on the same side of your transversal. And your last set is going to be angle 1 will be consecutive with angle 4, okay, on the outside of your parallel lines. Okay, and these, like your other consecutive ones, will always add up to 180, so they are also supplementary. Okay, so these are the 5 angles that you need to know: corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and consecutive exterior angles. Where you find them and how they relate when parallel lines are cut by a transversal.